Hi students, welcome to physics class. Today we are going to discuss some important points. Yes, note. Note. Now take consider it is capital R. Obviously it is also capital R. Consider this is delta theta. It is point C. Consider this is point P dash. It is point P. The time taken to travel from P to P dash is delta T. Now the distance covered is delta S. Here angular distance angular distance is equal to arc by length. Arc by length. That means that is equal to delta. What is arc? Delta S is the arc. What is the length? Capital R is the length. Once again, angular distance is equal to arc by length. That is equal to delta S by what is the length? Capital R is the length. Here delta theta is equal to angular distance. Angular distance and arc delta S is equal to arc and capital R is equal to length or radius. Therefore, angular distance is equal to arc by length. That means delta theta is equal to arc means delta S by R. Now it is a vector. It is a vector. The rate of angular distance is called angular velocity. angular velocity. It is denoted by omega. It is a vector. It is also a vector. Therefore, omega is equal to delta theta by delta t. Consider this is equation number 2. Once again, the rate of angular distance is called angular velocity. It is denoted by omega. It is also a vector. Therefore, omega is equal to delta theta by delta t. Equation number 2. If the distance traveled by the object during the time delta t is delta s. Once again I am repeating the point. If the distance traveled by the object during the time delta t is delta s, that is p dash is delta s. Now v is equal to delta s by delta t. Consider this is equation number 3. But delta s is equal to r into delta t. Consider this is equation number 4. Now equation 4 in 3. Therefore v is equal to r into delta theta by delta t. Consider this is equation number 5. But delta theta by delta t is equal to omega. Consider this is equation number 6. Now equation 6 in 5. Therefore, V is equal R into what is delta theta by delta t? Omega. This is main equation. This equation is equation number 7 and also called as relation between velocity and angular velocity. But A is equal V square by capital R. Consider this is equation number 8. Now equation 7 substitute in 8. Equation Equation 7 substitute in 8. Therefore, the acceleration A is equal R square omega square whole by R. Therefore, A is equal R omega square. Consider this is equation number 9. This is equation number 9. This is the relation between acceleration and angular velocity. Now see, note 2. Note 2. The time taken by an object by an object to make one revolution is known as its time period. Denoted by capital T, and the number of revolutions made in 1 second. Is called its frequency. Nu, denoted by nu, where nu is equal 1 by capital T. where nu is equal to 1 by capital T. Consider this is equation number 1. Once again I am repeating this concept. The time taken by an object to make one revolution is known as its time period, which is denoted by capital T, and the number of revolutions made in 1 second is called its frequency, which is denoted by nu. Therefore nu is equal to 1 by T. Next, during this time, the distance moved by the object is S. Therefore S is equal to pi r. Consider equation number 2. Once again I am repeating this point. During this time, the distance moved by the object is S. Therefore S is equal to 2 pi r. Equation number 2. The reason is velocity is equal to distance by time. Since velocity is equal to distance by time, therefore velocity v is equal to, what is the distance? S. What is the time? T. Consider equation number 3. Once again I am repeating, during this time the distance moved by the object is S. Therefore S is equal to nothing but circumference of the circle. S is equal to 2 pi r. Equation number 2. Therefore velocity is equal to distance by time. Therefore velocity v is equal to S by t. Consider equation number 3. Now 2 in 3. Equation 2 in 3. Therefore the velocity v is equal to, what is S? 2 pi r by t. This is equation number 4. Once again, what we get? V is equal to 2 pi r by t. This is equation number 4. But frequency is equal to 1 by t. Equation number 5. Now 5 in 4. Therefore V is equal to 2 pi r into 1 by t is equal to nu. This is equation number 6. Now may I write V is equal to 2 pi nu into r, but consider this is equation number 6. But 2 pi nu is equal to omega. Consider this is equation number 7. Now equation number 7. Now equation 7 in 6. Therefore V is equal omega into R. Consider equation number 8. But A is equal omega square R. This is equation number 9. Omega is equal 2 pi nu, that implies omega square is equal 4 pi square frequency square. This is equation number 10. Now equation number 10 in 9. Therefore acceleration A is equal 4 pi square frequency square into R. This is equation number 11. This is about relation between acceleration and frequency, acceleration and radius. Now note number 3. Note number 3. V is equal R omega. Consider equation number 1. Divided by T. V by T is equal to R by T into omega. Now the rate of change of velocity, acceleration, the rate of change of position is called velocity into omega. Equation number 2. The reason is V by T is equal to acceleration and R by T is equal to velocity. Okay, now equation 1. Substitute in 2. Equation 1 in 2. Therefore A is equal to R omega into omega. Therefore A is equal to R omega square. Consider this is equation number 3. But omega square is equal to 4 pi square frequency square. Equation number 4. Now 4 in 3. Equation 4 in 3. Therefore A is equal to R into 4 pi square omega square. Consider this is equation number 5. This is the relation between acceleration and radius and acceleration and angular frequency. I hope you understood this video. Thank you. Thank you very much for watching this video.